This question is from NEET 2019 paper code P1 question number 41. Question is 800 turns coil of effective area 0.05 meter square is kept perpendicular to a magnetic field 5 cross 10 to the power minus 5 Tesla, right? So in the first part of the problem, the information that is given to us is number of turns is 800, effective area is 0.05 meter square, and magnetic field which is perpendicular to the area, right, perpendicular to the coil, that is 5 cross 10 to the power minus 5 Tesla. When the plane of the coil is rotated by 90 degree around any of its coplanar axis in 0.1 second, then EMF induced in the coil will be. So we have to find out induced EMF, right? We know that induced EMF is minus delta phi by delta t. See, delta t is given to us, that is 0.1 second. The only thing that we have to find out is delta phi. Now what is delta phi? Delta phi will be phi final minus phi initial, right? Now what is phi initial? Initially the coil was placed perpendicular to the magnetic field, right? That means the angle between area vector and the magnetic field vector, that will be 0 degree, right? And when we have number of turns n, we know that flux is NBA cos theta, NBA cos theta, and theta in the first case is 0 degree. So the flux initial is going to be NBA cos of 0 degree, and flux initial is going to be NBA only, because cos 0 is going to be 1, right? Now what is final flux? See, now the plane of the coil is rotated by 90 degree, then angle between area vector and field vector, that will change by 90 degree. So the theta angle between them will be 90 degree now. So the final flux will be NBA cos of 90 degree. Now cos 90 is 0, so the final flux is 0, right? Now just put the values here. EMF will be flux final minus flux initial with a minus sign here by delta t. That means this is minus flux final is 0 minus NBA divided by delta time, which is 0.1, right? Now this minus minus will become plus, so the EMF will be NBA by 0.1. So what we can do now, we can just put the values. N is 800, and what is B? B is given to us. B is 5 cross 10 to the power minus 5 Tesla. So we can just put the values here. 5 cross 10 to the power minus 5. And what is the area? Area is given to us, that is 0.05 meter square. 0.05 divided by 0.1. Now if you will put all the values, then let's see what we are going to get. EMF will be, if you will remove that point, we are going to get 2 zeros here. If you will remove this point, we are going to get 1 0 in the numerator. So it will be 8000 now. Okay, now 2 0 and 2 0 will get cancelled out, right? And now we are going to get what? Just try to understand. This is now 5 into 5 into 80. So it is 80 into 25 cross 10 to the power minus 5, right? So what will be this quantity now? It is 200 into 10 is 2000 cross 10 to the power minus 5. So it is going to be, EMF is going to be 2 cross 10 to the power minus 2, right? This much volt, or we can say this is 0.02 volt, right? So this is the EMF induced. Okay, now let us go back to the options and see which option is correct. This option is correct, option D, 0.02 volt. Okay, thank you.